We'll continue our exam review, and we'll this time focus on the series and sequence unit. Here are the formulas that you will be given on the exam. If you have your arithmetic and your geometric formulas, notice with the arithmetic formulas you have a common difference, and with the geometric formulas you have a common ratio. First question, all right, this came off a quiz, I believe. It says find A, the first term, D, the common difference, and the general term, so a formula that would generate these numbers for the following arithmetic sequence. First thing we're going to do is we're going to use our arithmetic formula, and I can make a 2x2 system of equations out of this. If I know that term 3 is equal to 20, if I take my general term n minus 1 times d, and I'll do the same thing here with this information. Now, on this side, I can replace the n's with a 3. So term 3 would be equal to a plus 3 minus 1 times d, or term 3 is going to equal a plus 2d. With this information, I could say that term 10 is equal to a plus 10 minus 1 times d, or term 10 is equal to a plus 9d. So I replace the n's with a 3, and I replace the n's with a 10. Now, I can also make this distinction. If term 3 is equal to 20, and term 3 is equal to a plus 2d, then a plus 2d must equal 20. And by that same logic, term 10, or negative 29, must equal a plus 90. So I just filled that number, negative 29, in for term 10, and this number, 20, in for term 3. And what I have right now is a 2x2 system of equations. And I can solve this system of equations by subtracting. And if I subtract, this is what I end up with. I'm going to take this equation, and I'm going to subtract this one. 20 equals a plus 2d. It wouldn't matter what order you did this in. Negative 29 minus 20, that would give me negative 49. A minus a, there's no a's left. That's why it's called the elimination method. And then 9d minus 2d would leave 7d. I divide both sides by 7. And I get negative 7 equal to the common difference. From there, if I know the common difference is negative 7, I can solve for a by using either of these formulas. If 20 equals a plus 2 times d, then 20 is going to equal a plus 2 times negative 7. And 20 will equal a plus negative 14, or a minus 14. And I'm going to add 14 to both sides, and that would give me 34 equal to a. So here's what I know. I know that the first term is 34. I can check to see if this works. If I subtract 7, okay, that's going to leave my next term as 27. The third term, if I add negative 7 or I subtract 7, I get 20. Story checks out. That was given. And if I keep going, 13, 6, negative 1, negative 8, negative 15, negative 22, negative 29, you can see that the 10th term is also negative 29. Now, a lot of people stop there. They forget to do this part, the general term. To find the general term, I'm going to write down my formula. I'm going to fill in an a value of 34. I'm going to leave n alone, and I'm going to fill a negative 7 in for d. And when I simplify this, I end up with Tn equal to 34. This would be minus 7n. This would be plus 7. Group your like terms. 34 plus 7, that's 41, minus 7n. And that's the general term. If I wanted to know the first term now, plug a 1 in, I'd have 41 minus 7. That would give me 34. If I wanted to know the second term, I should get 27. Look, 41 minus 7 times 2, 41 minus 14 would bring me to 27. So I know I have the right general term. There's an example of an arithmetic sequence. The next question talks about a geometric series. Okay? It's helpful to write down your given information. It says if the sum of the first 5 terms, so they're telling me S5 is 1089, 1089. The common ratio, that's the R value, is 1/3. Find the first term. I want to find A. I use my formula for an geometric series, this one. Okay. Everywhere there's an R, I'll fill in a 1/3. Everywhere there's an N, I'll fill in a 5. How do I know to fill in a 5? Because they told me the sum of the first 5 terms. So N is 5. And if I fill this in, so here's the formula, Sn equals A left bracket R to the power of N, subtract 1, close the bracket, divided by R minus 1. So I'm going to replace the S5 with a 1089. I'm looking for A. I don't know what that is. I have 1/3 to the power of 5. So fill a 1/3 in here, subtract 1, and then a 1/3 down here, and I'll subtract 1. I end up with 1089 equal to A multiplied by 1 to the 5th is 1. 3 times 3 times 3 times 3 times 3, or 3 to the 5th, that's a 243. And then I go 1/3 minus 1 on the bottom. How do I subtract that? I got to get common denominators. So I'll have 1089 equal to A. In the brackets up here, I'll have 1 over 243 minus 243 over 243, 1 whole. And then I'm going to divide that by 1/3 minus 3/3. 1089 is going to equal A. In the brackets here, I'll have negative 242 over 243. And then I'll divide that by negative 2/3. 1 minus 3 is negative 2. 3, keep the denominator 3. When you're dividing by a fraction, we are going to keep the 242 over 243. Change this to multiplication and multiply by the reciprocal. So the reciprocal of negative 2/3 is 3 over negative 2, or negative 3/2. And I clean this up a little bit. That's going to give me a 121 and a 1. The negatives will cancel as well. 243 divided by 3, that is an 81. So that'll be a 1 there and an 81 there. And then I'll have the following. 1089 equals 121A divided by 81. So A times 121 times 1 is 121A. 1 times 81 times 1 is 81. I'll multiply both sides by 81. So that gives me 1089 times 81. Gives me 88,209 equals 121 times A. Then I'll divide both sides by 121. I get 729. So 729 is my A value. That's the first term. So there is part A solved for you. Find the first term. Part B, find the 9th term. So I got to use the Tn formula right here, A times R to the n minus 1. and I want term 9. My A value is a 729, my R value is a 1/3, and my N value is a 9. So I have 729, that's the first term, and I have a common ratio of 1/3. The 9th term means that N would be 9. Solving, I get T9 equals 729 times, this would be a 1/3 to the power of 8, which would be 1/6,561. Multiply top by top, bottom by bottom, and reduce. 729 over 6,561 is going to reduce to 1/9. So the 9th term is 1/9. Okay, first term 729, 9th term is 1/9. Last question. You're talking about a house that you purchased for $200,000. 4 years later, the house was worth $349,801.25. Calculate the annual rate of increase, assuming that the increase was geometric. So here's the move. Given information. I know term 1. I know A. So term 1 is your A value, and that's $200,000. Now, it says 4 years later, so understand this. You start at $200,000, and then you go 1, 2, 3, 4 years later, and you're at $349,801.25. So they're actually telling you term 1 and term 5. Okay, I know it's geometric. I know I can use this formula right here. And I'm going to fill this in for term 5, 349,801.25. It's going to equal, I'll fill a 200,000 in for A. I don't know what R is. I do know that N is 5. So I'm going to divide both sides by 200,000. Those would go away. It would leave an R to the 4th on this side, on the right, and 349,000 divided by 200, so 349,801.25 divided by 200,000. That gives me 1.749. And it goes 00625. I'll stop there. 4 decimal places is good. You could leave the whole thing in. Now I want to take the 4th root of both sides. Or I could raise both sides to the power of 1/4. So I could do this to get R, or I could do this. Either way, you're going to get R equal to 1.15. Okay. If I raise that to the power of 1/4, 1.15 is my R value. That's the common ratio, but that's not what the question asked me to solve for. It wanted the annual rate of increase. And this is expressed as a percentage. I go 100 times your R value, subtract 1. 1.15 minus 1 is 0.15 times 100 is 15%. And you could say the house increased in value by 15% each year. And that is that.